Hi, everybody. Thanks so much for coming to my talk. I know there's a lot of really good ones. One thing that I want to mention is that at 12 p.m. today, there's going to be a national emergency test. So any phone that is not on aeroplane mode is going to make a very loud noise. So I'm going to leave it up to you. You can either turn it off or you can embrace the chaos, and we will probably wait for a few minutes for that to pass. We'll see how it goes, but it doesn't matter if you're local or a tourist or whatever, it will go off if it's not in aeroplane mode, so just something to keep in mind. I also need to say thanks to Burnt Toast Creative for allowing me to use their illustrations in my talk. It does make it look very pretty, so at least you can enjoy that. A little bit about me. My name is Mandy. I am a Google Dev expert in web technologies, a Microsoft Regional Director, which is part of their MVP program. And technically, I am unemployed at the moment. But when I get back from this trip, I start a new job as a lead software engineer at Octopus Deploy, which basically manages continuous deployment and that kind of thing. So I'm really excited about that. It'll be really fun. You might have noticed I am Australian. I come from Perth, which is on the west coast, and that is currently where my dog Jello is being taken care of by my mum. I mention this because I use his pictures and his name in some of my examples, and if I don't mention that he is a dog, people sometimes get confused because his name is Jello. So when you see that word, you know that I'm talking about a dog and not the food. But that is enough about me. Let's get into the talk. And today what we're going to be talking about is how we can utilize HTML to improve the performance and accessibility of our websites and applications. What I'm going to do is run through why HTML is important, demonstrate its impact to accessibility and performance, and I'll briefly discuss some things to keep in mind when choosing the right HTML elements. For the last half of the talk, I'll focus specifically on HTML attributes you can use to improve the performance of whatever you're building. Now, I understand that there's a lot that goes into developing for the web these days, and as a result, we sometimes leave things like performance and accessibility to the end. But this is literally the worst time to look at these things. So, the purposes of today is to introduce you to some ways in which you can make the most of HTML to lay a really good foundation for addressing these two aspects of the web development process. For those that are unfamiliar, when I refer to accessibility, what I mean is the practice of making your websites sensible, meaningful, and usable to as many people as possible. Typically, and most importantly, this refers to people with disabilities, making them accessible for assistive technology like a screen reader. And in the same vein, web performance has similar goals in that we want to ensure what we are building can be accessed quickly, efficiently, on a wide variety of internet connections and devices. Again, so that we can reach as many people as possible. For performance, it can include things like perceived performance, actual speed, smoothness, interactivity, and of course, overall load times. The easiest way to get started with both of these things is with HTML. I'm going to be really upfront because I know some of you are probably thinking it. HTML is really simple, and it's a very friendly language, but because it's simple, we often make the mistake of assuming that it's not valuable. And I'm really hoping to dispel that way of thinking if that is what you're thinking, because as something that we use in pretty much everything that we're building, it plays a really pivotal role in making good functional websites and applications. Now, to set the scene a little bit, we have our HTML, right? Whatever we're building typically has that. And then the browser takes that HTML and it interprets it. But it doesn't just take it as is, it actually converts it to a big long string of text, and then the browser has to parse it. And it'll go through this string and it'll start constructing those parent and child relationships that you're used to seeing when you inspect your code in the browser. And that's known as the DOM tree, or the document object model, which we use to manipulate, edit, and move things around on the page. There are a few other steps like compositing and layout, but they are not important for the purposes of today. What is important is the DOM tree, because that's what makes things functional. And it's constructed off what we provide the browser via HTML. If we request a div, it's going to create a div. If we request some kind of made-up component, that's what it will create. So, I'm going to talk about TypeScript for a minute here. Trust me, it'll all make sense. I know that when people say trust me, you immediately want to not trust them, but let's just go with it. Who's familiar with TypeScript or any kind of typed language? Great. So many people. When I first asked this question like 6 years ago, it was a lot less, so it's come a long way. For those that didn't raise their hand, very simply, with TypeScript, when you're writing your JavaScript, you can assign a type to your code, and then TypeScript will check that at compile time, and if the value and type don't match, it's going to throw an error. So we might have something like this. We have an interface with some data, and we're going to choose a type to assign to that data, whether it's a string, a boolean, or a number. We pick something that makes sense to the relevant piece of information. And if we're using TypeScript correctly, we're being really explicit about what the shape of our data should be. This makes debugging, writing, reading, and working with our code a lot easier. And as a result, we typically get better output. This is essentially what we do when we write our HTML. We specify what kind of heading it should be, whether it should be a list, navigation, bold, italic, dates, forms, inputs. There's a whole suite of elements we can use to best represent our content. And we do this for similar reasons that we might use TypeScript. To define the shape of our content to make it easier to read, write, and work with. All we're doing is assigning a type to our content. And in TypeScript, we have the concept of an any type. If you assign a type of any, it means the data can be anything. But if everything is typed as any, then you lose the benefits of the language. This is the same in HTML if you use divs everywhere. You're not making the most of the language. Because of this, it's really important that you actively choose what the right element is, and you don't just default to a div. Because if you choose a generic element, you're going to get generic output. So for example, this is a div-only page. It does have some links, which I've added some JavaScript to. And when you look at it, it's kind of like a big blob of text. It's okay because it's a simple page and you can probably figure it out, but it's not very good. If we use more meaningful HTML, you can immediately see there's a much better structure. You can see what a link is. Overall, it's a lot better. And you could fake this with CSS, but that's just cosmetic. And you could fake some of the functionality with JavaScript, but not all of it. And it's also heaps more work for you, so why would you bother? But the main issue here is that it's hugely problematic for accessibility if all you're using is divs. Because not everyone and everything is going to interact with your page or application the same way. Many different technologies try to use, read, or consume your content, and they rely on us using the languages correctly in order for it to make sense. So whether it's Google search bots, reading apps like Safari's reading mode, text-to-speech tools, or accessibility devices like a screen reader, it's not just our eyes that are going to consume our content. And the DOM and the HTML play a really big part in how successful people and technology will be. Now, much like the browser creates the DOM, it also takes the DOM tree and it modifies it to form something that's useful to assistive technology. And that is known as the accessibility tree. The accessibility tree uses the native semantics of HTML to navigate and read the page. So a screen reader, for example, is able to interpret the accessibility tree and reproduce it as speech. Browsers like Chrome and Firefox have accessibility tree inspectors. This one is from Firefox. And what it does is it allows you to see what the accessibility tree, what assistive tech would see when it's trying to interpret the page. Because the accessibility tree is made up of what we provide the DOM via HTML, if you only use divs, what it provides is a bunch of sections and text leaves. So as far as the accessibility tree is concerned, all the page has is text, which means you don't have any features or functionality. If you use more meaningful HTML, you get a lot more information. It knows if something is a list, a link, a heading, a section. And along with that, you get a lot more information and features. A good way to demonstrate this is to listen to what a screen reader might sound like with our very simple page. So we'll start with the div only using Mac's VoiceOver. There are a number of different screen readers, but we'll use the Mac one because that's what I had access to. Are you ready? I apologize for the voice.
Home. Good dogs. Bad dog myths. Dogs, they are good. We are dedicated to educating the world on why dogs are good and how they can make your life good. By Mandy Michael, August 3, Road 2018. Why are dogs good? Dogs are loyal, intelligent, devoted and affectionate. They are known to improve our physical and mental health. Jello, also known as Jello. /screen percent 20 shot percent 20.
Okay, I won't make you listen to that. That was a screenshot from Instagram. I didn't rename the file and I didn't add an alt attribute. So use alt attributes for meaningful images and rename your file names because that's terrible. A couple of other things you may or may not have noticed. It didn't tell us that there were any links on the page, and that's because as far as the accessibility tree is concerned, there aren't any. It's just text. You might be able to figure it out from home, but anything else within the page might be more confusing. It also read the date out very terribly. It said August 3 Road 2018, which was not very nice. No headings, no structure. And all this from a very small part of a very simple page. So if you think about more complex pages and applications, how confusing things like this might become. So let's listen to a page with better HTML.
Navigation main navigation 1 item. List 3 items. Visited. Link. Home. Link. Good dogs. Link. Bad dog myths. Heading level 1. Dogs, they are good. We are dedicated to educating the world on why dogs are good and how they can make your life good. Mandy Michael, August 3rd, 2018. Heading level 2. Why are dogs good? Dogs are loyal, intelligent.
Okay, you get the point. The date was better because I used the time date attribute. It told me how many links there were in the page, that I'd visited them, that it was a navigation section. The image is better. I won't make you listen to that again. There's headings and there's a structure. Overall, there's a lot more context, which makes it a lot easier for the user of assistive tech. And again, this is just a really simple page. So by selecting our HTML more carefully, what we're doing is some of the heavy lifting for the user and the assistive technology. In this case, the screen reader. It gives it the information that it needs in order to present the content in a more meaningful and useful way. And the end result is a much more functional page. And it's not just the accessibility that benefits from a more considered approach to HTML. Overlooking HTML can lead to a large, messy, complex DOM tree. And as users and scripts interact with the page, the browser has to recompute and position the styling of each of the nodes. And this can severely impact the runtime performance and the rendering time of whatever you're building. Google's Lighthouse performance tool recommends less than 1,500 nodes on a page. It will warn at 800, so you should take that as an indicator to have way less than that. Max depth of 32 nodes, no parent node with more than 60 child nodes. And you're probably thinking that's a lot. And in some cases it is, but it's quite easy to accidentally exceed these, particularly these days when a lot of us are building at a component level. And we add lots of wrapper divs in this component and wrapper divs over here, and we've got component wrappers. We kind of forget that all of this stuff has to come together on a page. And I know that people check that the component works, but how many of you tested and looked at the actual HTML that was being output for everything on the page every time you build something new? Probably not that many of you, because I see it a lot where people don't actually check. So you should pay attention to when and where you add HTML on the page, and you want to aim to create nodes only when you need them. This is particularly true if you're working with single page applications, because the JavaScript frameworks have to manage all those nodes as well as the browser, so it can make things actually a bit worse. Don't fill your page up with stuff that's not necessary because it's going to contribute to poor performance as well as bad accessibility. If you think about that screen reader before, it's got to read all that stuff out as well. Now, as the accessibility tree is made up of what we provide the DOM, any performance impacts to the DOM have an even greater impact on the accessibility tree. So I saw a great talk by Eric Bailey. He's an inclusive design advocate. He's doing work with GitHub at the moment. And he said this quote, which is great. When the accessibility tree is slowed down by excessive code, it can create a lack of synchronization between the current state of the page and what is being reported by assistive tech. This results in a mismatch between the page and what the user is presented with via the accessibility tree. As you can probably imagine, that's very confusing. It's kind of like really bad lag or bad dubbing. Not really clear what's going on if that happens. Even worse, a really large, complex accessibility tree that's based on a large, complex DOM can actually crash the browser, which means I won't be able to use your page at all. At the end of the day, everything we put into our pages and our applications adds up, including the HTML, every div, every link, every button. So don't just throw stuff in. Dedicate some time to how and where you use your HTML. So this was kind of a really long-winded way of me saying don't just use divs. I'm not saying don't ever use them. They do have a purpose, just don't only use them. And when you're using better HTML, a good tip is use the named element for what you're building. If you have a header, use a header. Footer, footer, nav, nav, article, article, label, label, form, form, button, button, section, section, image, image. I will concede that anchor and link is very confusing, but they are old ones. The new ones are designed to be intentionally simple. They are named to help you out. It's not a trap. And look, I know that it's not always that straightforward, but it is a really, really good place to get started. And MDN is a really great resource that you can look at. There's only about 115 actually in use HTML elements at the moment, so it's not really that much. Day to day, most people use about 20. Now, when you've picked the HTML element that is most appropriate, make sure you're using them correctly. Headings are a really good example of this. They are numbered for a reason, so please use them in order. They provide a clear structure and hierarchy for the page, and when you use them out of order, you mess with that hierarchy. They're really important for a number of reasons. At the moment, I don't know how long it will last for because of AI, but who knows, Google Search Bot uses headings to determine content hierarchy and what is most important on the page, so think H1, H2. But most importantly, they are very important for accessibility because like we might scan the page to find what we're looking for, users of assistive tech will do this via headings. And they'll use tooling in order to find those headings. And it might be keyboard shortcuts or it might be something like this. This is the rotor. This is the Mac OS rotor, which you can use with VoiceOver, but other screen readers have it as well. It's sort of like a table of contents, and it groups things like headings, landmarks, links, all together in that little box, and they can navigate through and jump to a section on the page. So if you don't use headings, you take away this functionality. It is not possible without the use of them. If you don't use them properly, you make this functionality less helpful. So make sure that you're using things correctly so that features like this can be utilized by your users. Talking about functionality and features, more often than not, you should favor native functionality over creating your own. And again, I know this isn't always possible, but it is a really good place to start. There's a lot of useful built-in features to HTML that don't require additional JavaScript, and they tend to work better across mobile operating systems and assistive tech. Not always, but they typically are better than whatever you're going to get off Stack Overflow, if we're still using that. AI's made everything very confusing for me. We'll see. A couple of examples. The details component, which is like an accordion. Or a very common one that I'm sure you're all familiar with, seeing these date pickers all over the internet, is the input type of date. The reason that I've included, here we go. I don't know how long this will go for. I was expecting it to be way louder than that. Just have my water now. There we go. That's definitely what I was expecting. It's like, where's it gonna go next? Okay, I think we might be good. I'm so glad that didn't happen at my... I was tricked. This is a trap.
That's outside. Yeah, that's outside.
Should be done? Shall we risk it? I'm so glad this didn't happen on my next slide, because it has a semi-controversial statement, and if I didn't get a chance to explain myself, like, you would have been horribly judging me. Where was I? Input type of date. It's all right. Do you have something important you want to share with everyone? No? Yeah? All right, we'll try again. So with this, with the date pickers, the reason that I included it is because it's kind of one of those situations where you may or may not want to use it. This is fun. That's really loud. That did sound like outside, yeah.
And you can hear that almost all the way to the airport as well.
Gosh. I was told this happens like regularly. Yeah. We don't have this. We don't have this in Australia. Sounds like a boat.
Yeah, it's like typhoon alarm.
Yeah. We don't get typhoons, so. Well, at least where I am anyway. We just get sun and the occasional cyclone. I don't know how long I should wait. Shall we try again? I'll try again. We'll see how we go. So yeah, with the date pickers, it's kind of a question about whether or not you should use them. So I did say use the named element, but it's not always the case. So date pickers are great for discoverable dates, like we're going to have an alarm every 6 months from now. They're not great for known dates, like date of birth. I don't know how the average age of everyone in here is, but the older I get, the more humbling these date pickers become, because I have to click back quite a way to get to my year of birth, and it's sometimes deeply, deeply painful to remember how old I am. Thank you. Yes, that's exactly how I feel. I am so glad it didn't end on the last slide, because that would have been, this next one, it would have been really awkward. So you basically feel like I should tell a joke, but none are coming to mind. They did warn me it might be like 5 minutes. Gosh, this is so severe. I don't know if let's try again. What was I saying? God, I've lost my train of thought. Oh, dates, yeah. So with known dates like date of birth, just using an input with a text input with some guidance on how you want the format to be is much easier than using something like a date picker. So while you should use the named element for what you want to build, you also want to make sure that it's not going to be a huge pain in the bum to find the information that you want with that feature. There's a really great article about this by Adrian Roselli called You Might Not Need a Date Picker, and he goes into this problem and he talks a little bit about how you can make the text inputs more accessible. I've linked it in my resources. I highly recommend everybody read it because I would love for people to not use date pickers for date of birth and other similar dates. Now, the other thing about date pickers that you might come across is that people like to build custom ones because the designs don't match the native implementation. And what I have to say about that, in my potentially controversial slide, is that just because it's in a design doesn't mean you have to do it. Now, if this alarm went off here, some of you would be like, what? Design is so important. And it is. And I'm not saying be a jerk about it. I'm not saying disregard design. I'm not saying ignore everything that they've done. What I'm saying is you can always ask if something is necessary. You should never be afraid to discuss potential changes if it's going to make more functional, performant, or accessible changes to your application. Design and development are not separate, particularly on the front end. They should be worked on together in collaboration. There's always room for compromise with this stuff. So you don't have to do what's in a design. You can ask, hey, can we make this change so I don't have to spend a week trying to figure out this date picker library to make it accessible, whatever. So just because it's in a design does not mean you have to do it. That said, there's a lot of features that have quite good control over styling. The dialogue is a good example of this. It's kind of like a modal or an overlay where the page behind it is disabled until the action is complete. Or related but different is the popover. Popover is different to the dialogue in that the page isn't disabled behind it. So this is great for toast notifications, form elements, suggestions, content pickers, teaching UI, that kind of thing. This is actually very new. It was only supported in browsers as of February this year. And if you watched any of Google I/O, you might have seen some stuff that they talked about with this. Things to do with anchor positioning of the popover, styling for this. So they're actually introducing the ability to animate these things in and out with just CSS. No JavaScript needed, which is awesome. So lots of features coming with popover, and it's very useful in particular for applications. So something to watch out for. And of course, really good example of an element that comes with lots of features is a button. Now, I know we've had the don't just use divs discussion already, but this is still something a lot of people do instead of using a button. They'll use a div. The problem with this is that buttons come with lots of functionality, particularly for accessibility. Things like keyboard interaction, focusable, being announced via the assistive tech, reported to the accessibility tree, all of which a div does not do. In order to make a div do this stuff, you need to add a tab index, a role, and aria pressed to the HTML, and then you need to write at minimum this amount of JavaScript. This is not everything that you would need to do, it is just the bare minimum. It's a lot of code for something that you would get for free with a browser and with HTML, because not only do you have to write this, you got to test it and you got to maintain it. It's completely unnecessary JavaScript that you're adding into whatever you're building. I know that sometimes people use a div because they don't like the default styling that browsers apply. Instead of using a div, use this button CSS reset by Andy Bell, copy that into your CSS, and it will give you a button that looks like a div. And then you'll get all of the nice features of a div and none of the visuals of a button. Sorry, you'll get all the nice features of a button and the visuals of a div. Same applies for anchor elements for links. They come with a lot of pre-built functionality, so you should use them instead of divs. When you make the most of native functionality, it's basically like using a JavaScript library that's already built for you and already installed. It's one less NPM package, which means it's less JavaScript, which means you have smaller bundle sizes, and we like that because it improves our performance. So just by using HTML and the features it provides, you're already improving your performance and your accessibility. Now, much like elements have a lot of useful features, HTML attributes also come with a lot of pre-built functionality that you can take advantage of. And a good example of this is ARIA attributes, which are a collection of attributes designed specifically for the accessibility tree. They loosely aim to fill in the gaps of HTML to give more context to the accessibility tree. Now, there is a whole heap of them. For example, ARIA pressed, selected, expanded, and grabbed do what you might expect. They indicate that that action has occurred on an element. ARIA Live indicates that an element will be updated, so this is really good for shopping carts, status updates, stuff like that. To-do lists as well, like when you added something, it's like, hey, this has been added. If you're doing code tests and want to be extra fancy. ARIA Hidden hides elements from the accessibility tree, so if it's decorational, the screen reader doesn't need to read it out, you can use ARIA Hidden. And ARIA Labeled By will identify an element that a label applies to, which is really common in forms, and you've probably come across it from time to time. To be honest, I would need a whole separate talk to go through all of this. So instead of going through them all, I'm going to give you some advice from a friend of mine. She is an accessibility expert in Australia, but she also talks internationally. And she said that if you're writing CSS or JavaScript that conveys information, ask yourself, is that information also available to the accessibility tree? If not, a bit of ARIA might help. They're particularly useful for any custom complex interactions. So for example, if you're making some kind of fancy drag and drop thing, ARIA can be really useful there to provide that information to the accessibility tree so it can communicate better with the users. And if you're not sure if you need it, you can use the accessibility inspector or use a screen reader to test it to see where you might be able to fill in those gaps and provide a bit more context. Okay, so we are at the halfway point, slightly behind because of the beautiful noise. But now we're going to focus specifically on loading and performance. And we'll start off a bit easy by talking a little bit about image performance, because images typically take up more bandwidth than any other resource, and they tend to be one of the biggest impacts to performance. There's a lot of things you can do, managing your file sizes, using modern image formats, but there's also some HTML approaches you can take as well. Now, I almost didn't include this next one, but it's really important, and it's the easiest way to improve the performance of your page. And that is adding a width and height to your images, because what this will do will improve the effect of the cumulative layout shift, which, as an aside, I have spent so long trying to say that word. It is very difficult to say in front of a bunch of people, and I'm so chuffed that I just got it right. Let's see if I can do it again. So the cumulative layout shift measures how much elements on the page shift as content is being downloaded. With images, this is particularly important because there's typically a delay between the HTML and the image being downloaded. And this can cause any content below the image to be pushed down the page, causing a layout shift. Really disruptive and annoying, especially if you've already started reading, because it's going to start jumping down the page. Now, you probably notice this a lot on mobile devices because of the smaller screen real estate. But the problem with this is it can become even worse. If you think about, this is one image. If you had another image below it, that loads in, pushes everything down again, and then it happens again. It's kind of like a domino effect. And this domino effect can significantly increase the work of the browser as it has to recalculate the layout every single time an image is loaded in. So by adding the width and a height, you kind of reserve the space for the image, meaning that the browser doesn't have to recalculate all of the nodes in the page every time an image is loaded in. It's just going to load in place. Now, going back to the date of birth thing, if you were around pre-responsive web design, you will note that we used to do this all the time. We used to add a width and a height to our images. But when responsive web design became a thing, we stopped doing it because you can't have a 1,000 pixel wide image on a 400 pixel wide device. So we had to add in some additional attributes to manage this. And the first one is source set, which allows you to provide a comma-separated list of image file names with a width or density descriptor. So the density is the DPI of the image. In this case, I've defined two images. One, Jello 1000, which is 1000 wide, and Jello 2000, which is 2000 wide. The 1000W indicates what the width of the image is so that the browser doesn't have to download it to know what the size is. Sometimes people think that the 1000W means width of the viewport. It does not. It means width of the image. If you want to determine which image to use based on the width of the viewport, you can use the sizes attribute, which allows you to define media conditions like we do in CSS. So we can say, at a min width of 1,000 pixels, I want to load a 1,000 pixel wide image. And then it will go to that source set and it will pick the one that matches. In this case, the 1,000 wide image. If there isn't one that matches, it will pick the next largest one. So in this case, I've not specified a 400 pixel wide image, so it will go and load 1,000 regardless, which isn't great. But that's what you can use source set and sizes for. Now there are a bunch of other things you can do, especially in CSS. You can utilize aspect ratio to help in this area, but that's CSS, not HTML. So instead, we're going to move on and talk about lazy loading. I'm going to be totally honest here. I pretty much included lazy loading so that I could show you a bunch of pictures of Jello, which you get to enjoy now. Essentially, what lazy loading does is it defers loading an image until it reaches a particular distance from the viewport. It looks something like this, and as you scroll, each image is loaded in rather than all at the start. Previously, we would have handled this with the intersection observer or event handlers like scroll and resize. But for quite some time now, HTML has had this built in. To utilize it, you can add the value of loading, attribute of loading with a value of lazy to a valid element, images and iframes, which is awesome for ads if you're having to deal with that, like I had to for a long time, really terrible. And that's all you have to do. That will work. You don't need any extra JavaScript. It'll all just function with a small caveat. Some of the browsers require you to specify a width and a height for lazy loading to work. If you don't provide a width and height, it will ignore the lazy loading feature and it will not lazy load. The reason for this is basically what I just explained. If you lazy load and you've not set a width and a height, it will affect the cumulative layout show, so it's going to start pushing all that content back down the page. So you're kind of undoing the benefits of lazy loading by not having a width and a height. So do make sure that you add a width and a height to images that you're lazy loading. Now, the default value is eager. That is the same as not including it at all. The reason I mention it is because some image management components or libraries will lazy load by default. So Next.js, for example, I think the WordPress one does it as well. This is great because we want to lazy load our images for the most part. However, we only want to lazy load images that are not in the viewport when the page first starts loading. If an image is in view when the page first starts loading, so that top part of your page, This is considered part of the largest contentful paint. And the largest contentful paint is the render time of the largest image or text block that's visible within the page when it first starts loading. If you try to lazy load an image that's part of this, you're going to negatively impact your performance because you've deferred the image. So it's going to take longer to download, and it's going to affect that largest contentful paint metric because it's not going to be ready in time. So if you are using Next.js image component or any of these kind of image management things that lazy load by default, you need to reset it to eager if it's in part of the largest contentful paint. Otherwise, it's going to do the opposite and cause you performance problems. Support's really good. It's been around for a while. The only thing it's not supported in is Internet Explorer. If you are still supporting Internet Explorer, I'm very sorry. I can't help you there. That really sucks. So, for the remaining of the talk, we're going to talk about loading and prioritization and how we can optimize that with HTML. I'm going to give a very simple, basic rundown of prioritization, just to set some background for you. It's a very complex area, so when I say basic, I mean basic. Let's do the best that we can. So, with prioritization, in HTTP 1, browsers would typically open multiple TCP connections and it would load one resource at a time. So prioritization was based on whatever was requested first. However, in HTTP 2 and HTTP 3, rather than multiple connections, it was typically changed to a single connection with multiple requests. But that doesn't mean that all the requests can be responded to at the same time. Sorry, but because that's not how it works, right? This is because a connection is limited in how much data that it can send. And that's particularly true at the start of a connection because data is limited for each network round trip. As a result, the server's going to decide what to respond to first. This means that the order of prioritization can have a big impact to the performance of your website or application, because as it prioritizes one thing, it's going to deprioritize another. So if you send your JavaScript first, your images will be delayed and vice versa. And this is particularly important for render blocking resources like JavaScript and CSS because they need to be downloaded in full before they can be applied and executed on the page. And even more confusingly, browser prioritization actually varies between browsers. It is not the same. So you might notice differences between Firefox, Chrome, Safari, Edge, depending on how you have things set up. So one of the ways that we can sort of handle these issues is with priority hints, specifically the fetch priority attribute. What fetch priority does is allow you to specify the priority that you want for resource types like CSS, fonts, images, and scripts. And it'll allow you to suggest to the browser what important level it is, but also try and resolve some of those discrepancies between the browsers by providing that information. It has 3 values. High means you want to prioritize it. Low means you want to deprioritize it, and auto means you're happy to let the browser do its thing. That is the default. Now, often people will expect if you set it to high, it'll be the highest priority, and if you set it to low, it'll be the lowest priority. That is not what it does. It actually sets a relative priority, so it will raise or lower the browser's default priority by a specified amount. So it's kind of more like a suggestion than a demand. As an example, this is from web.dev, so it is Chrome-based. We have a critical CSS style sheet. If we set, its default priority is the highest priority because it's a render blocking resource. If we set the fetch priority to high, it's going to retain the highest priority, which is great. If we set it to low, it's not going to become a low priority. It's just going to be downgraded to a high priority because it's still important as far as the browser is concerned because CSS tends to be render blocking. So in neither of these cases are we explicitly saying it's high or low. We're just adjusting the relative priority. Unfortunately, the browser rules are not very well documented. There is some information online. Robin Marks has investigated it a little bit. I've linked to his resources. Probably his is the best I found, so you can go check that out in my links at the end. But it's kind of unclear, so it is a bit of a trial and error thing, unfortunately. An example of a place that you can use this really well is image carousels that marketing teams love so much, particularly if it's in that largest contentful paint area on your page. If you set the fetch priority of the main active image to high and the remaining images to low, it will fetch that first image more quickly and improve that largest contentful paint metric because you've deprioritized the other images that are not currently visible. Browser supports very good Chrome, Safari, and Edge, as well as their mobile counterparts. It's not supported in Firefox, but my understanding is that it's being worked on, so hopefully it will be this year sometime, but we'll see. But the thing about HTML, and this is one of the things that makes it so great, is that if a browser doesn't understand it, it will ignore it. So you can use this without any kind of polyfill or anything like that, and it'll work in the other browsers, and then when Firefox eventually sorts it out, it'll work in there as well. So the next thing we're going to look at is requesting resources. So requesting a resource from the server can take a really long time. So if you can handle this ahead of time, you can make your applications and websites feel a lot faster. We do this using resource hints. There are two options that we'll talk about, pre-connect and DNS prefetch. You use these on the link element with the rel attribute with a value of pre-connect or DNS-prefetch. Looking at pre-connect first, essentially it's going to inform the browser that your page intends to establish a connection to another domain and that you want it to happen as quickly as possible. This can speed up your load times by about 100 to 500 milliseconds. 500 milliseconds is actually a lot. If you can do that, I'd be really impressed. More likely it's probably going to be about 100, but see how you go. You'll find this really handy for image CDNs, streaming media, links where you don't know the exact domain or where it might change, something like Google Fonts, for example. This will establish that early connection and save you a bit of time. However, if you are making a lot of connections to third-party domains, pre-connecting all of them is going to be counterproductive. It's kind of like if everything is important, nothing is important. So it's best to keep pre-connect for only the critical connections. For everything else, you can use DNS prefetch. That will save time on the first step, which is the DNS lookup, and it will usually take about 20 to 120 milliseconds. Now, 20 milliseconds might not seem like a lot, but in this case, in a positive way, it does add up. You want to aim to try and save many small incremental improvements as much as possible with the things that you're adding into your page, because that will all add up and make a difference to the final performance. It's quite difficult to get like 500 millisecond changes regularly, so the more smaller changes you can make, the better. Pre-connect has really good support. DNS prefetch, however, is only supported in HTTP, not HTTPS on Firefox, hopefully soon. It's also not supported in iOS, Safari, and the Android browser as of yet. But again, you can still use it. It'll just be ignored in the browsers if it doesn't know what to do with it. So finally, we're going to talk about preload. And I left this to the end because it's probably the most commonly used HTML attribute for performance. It's also the most misunderstood attribute. We use preload the same way that we use pre-connect and DNS prefetch. A value of preload with the rel attribute on a link inside the head of our document. And it'll tell the browser to cache the resource so it's available immediately when you need it. What preload does is it helps to prepare resources that you don't need right now, but you're going to need later. But again, when you preload one thing, you're going to slow down the loading of something else. So we only want to preload those critical connections. Unfortunately, as I mentioned before, it's quite misunderstood and people mistakenly preload all of the things and they use it everywhere and in the wrong places. And this can actually make your performance worse. I thought this tweet was really funny from Zach Leatherman. If you look into the performance experts when they talk about preload, they actually really hate it because of how badly it's used. And in response to this tweet, Robin Marks did this tweet, which I'm going to use to explain why preload can be problematic. So what we have here is a HTML page, some JavaScript, and the image, which is in green. And it shows how each resource is being downloaded. Now, without preload, they download one after another, and it takes about 2.25 seconds, which is kind of a long time. In HTTP 1, with preload, if you're lucky, the image will be requested alongside the JavaScript, and it'll all download quicker in about 1.75 seconds. 75? Yeah. Huzzah. Great. Unfortunately, that's probably not what's going to happen. In HTTP 2, if you're unlucky, and what's probably going to happen is the image and the JavaScript are going to fight for priority and bandwidth, which means that the image is going to impact the download of the JavaScript, making the JavaScript slower, and potentially the image could download before the JavaScript, resulting in a really janky experience. So in this case, downloading it without preload probably would have been the better choice. Therefore, you need to be quite careful in how you use preload, because although it's a great feature in HTML, if you're using it wrong, you could actually be making things worse. So do make sure that you test these things and don't just whack it in and leave it. We can use preload for assets that aren't loaded by our HTML directly, but are critical to the experience of the page. So resources that are inside CSS, like fonts or images. With JavaScript, critical chunks of JavaScript bundles, or again, resources that the JavaScript can request, like JSON or imported scripts or web workers. And you can also use preload for large files to start preloading them and to cache them. Preloading is really good for things that you know the exact URL of. So I said Google Fonts for pre-connect because the URL might change, but with if you're hosting your fonts yourself and you know the exact URL, preload is really good for those. So to finish off, I wanted to briefly mention early hints. It is not HTML, so you might be thinking, why am I mentioning this? What it is a new HTTP status code, 103 early hints, and it defines new interactions between a client and the server. And the reason that I'm bringing it up is because all the things that I just talked about, DNS prefetch, pre-connect, preload, fetch priority, can all be used as part of early hints. So for example, oh, it's going off again. That was a surprise. So with early hints, it'll allow a browser to pre-connect to sites or start preloading resources even before it has prepared and sent the final response. So while the syntax is a little different, this is from MDN, looks a bit like this. What I thought was really cool about it was the transferable knowledge. So if you live in one world more than the other, it's a great way to, expand your knowledge in HTML or status codes. And also you might find that something like preload works better in early hints versus HTML and vice versa with some of the other options. So it's a really good place to experiment and try different things. It's got pretty good support. Preload's not currently supported in Safari. I gave this talk like a month ago somewhere else, and it was behind a flag in Firefox, but it's not anymore, so that's awesome. The support is coming quite quickly. Now, to finish up talking about performance, these are really great features, and they're a really good way to set that good performance foundation for your site. However, if your images are 20 megabytes and you have a bazillion megabytes of JavaScript, it's not going to do anything. So it's really important that you manage your resource file sizes, you manage how much other things you're putting in the page as well, and you use these in conjunction with good practices regarding file sizes. Otherwise, you're just gonna have a bad time all around. So, on that note, that was kind of a somber note to finish on. I apologise. Let's try and finish this a bit better. Please make the most of your HTML. You can make it much more usable and much more useful, not just for performance and accessibility, but for your users, different technologies, and the developers working on your products as well. Don't just use divs, try and use the right HTML elements where you can. And you can improve the performance and accessibility all by using a technology you're already using, just using it like a smidge better than you were before. Because there's so much to be gained from making the most of HTML, and there's literally nothing to lose. You can make really big improvements and set a really great base for yourself just by looking into HTML and using it a bit better. And it is a simple and friendly language for everyone here who is, I'm sure, very smart, doing much more complicated things. You can utilize this really well and make your lives so much easier. Thank you very much. I will be around if you have any questions. We're pretty short on time, so come and chat to me or contact me on any of the social networks. Also happy to talk about dogs. Thanks very much.